Welcome to Spaceverse, your portal to cosmic adventures. Einstein's theory of general relativity fundamentally transformed our understanding of gravity. Before his work, gravity was considered a straightforward force between masses. Einstein revealed that gravity is not just a force, but a result of the curvature of spacetime caused by the presence of matter and energy. Massive objects like stars and planets bend spacetime around them, creating the gravitational effects we observe. This revolutionary perspective impacts everything from planetary orbits to the bending of light and the universe's expansion. According to this theory, the fabric of spacetime itself warps and distorts in response to the presence of mass and energy. This curvature of spacetime then dictates how both energy and matter travel through it. Normally, light moves in a straight line, but when spacetime is curved by a massive object, gravity can bend and amplify its path. This fascinating phenomenon is known as gravitational lensing. When massive cosmic structures like galaxies or galaxy clusters bend the light from objects situated behind them, they act as natural lenses. This bending effect magnifies and distorts the images of these distant objects, much like how a magnifying glass can alter the appearance of things viewed through it. It allows us to see and study objects that would otherwise be too far or too faint to detect. Thanks to this natural cosmic lensing and the advanced capabilities of the James Webb Space Telescope, we've been able to look back to the very beginning of the universe. This incredible technology has enabled us to observe 5 exceptionally dense protoglobular clusters, which are among the earliest formations in the cosmos. The findings are pushing the boundaries of our knowledge and revealing that the early universe was far more complex and fascinating than we had ever imagined. The James Webb Space Telescope has made an incredible discovery. It might have found the universe's earliest star clusters. The telescope spotted 5 protoglobular clusters, dense groupings of millions of stars held together by gravity within the cosmic gems arc. This galaxy, forming just 460 million years after the Big Bang, resembles a delicate crescent and is the most magnified region we've observed from the universe's first 500 million years. This stunning view offers a unique glimpse into how the first stars helped shape galaxies during the cosmic dawn. In the cosmic gems arc, astronomers have discovered 5 newly forming globular clusters, each about 3¼ light-years across. These clusters might contain some of the universe's earliest stars and offer new perspectives on the reionization epoch, which has been a challenge for our cosmic models. During reionization, the universe was enveloped in neutral hydrogen, creating a cosmic fog that obscured our view of the early universe. This hydrogen eventually became ionized, clearing the fog and marking the cosmic dawn, the earliest observable moment after the Big Bang. The exact processes that led to this ionization and the clearing of the fog remain uncertain. These globular clusters could be key to understanding this period, as they likely played a crucial role in the transition from the cosmic fog to the cosmic dawn. The early universe is very different from what we anticipated, noted Angela Adamo, an astronomer at Stockholm University. Galaxies are far more luminous, form stars at an astonishing rate, and do so within massive, dense star clusters. We're rethinking our understanding of how early galaxies developed. To delve deeper into the early universe in this area, researchers are set to perform a spectroscopic analysis using the JWST. This will enable astronomers to assess the physical characteristics of the clusters, update their age estimates, and understand how these cluster stars impacted their neighboring galaxies. With the universe estimated to be 13.8 billion years old, models suggest that the reionization period began around 375 million years after the Big Bang and likely ended roughly a billion years later. This situates the cosmic gems arc in a time of ongoing reionization, making it unlikely to find older objects. However, the Webb telescope has recently pushed boundaries, uncovering the oldest galaxy ever observed, exceeding the cosmic gems arc's age by over 100 million years. In October 2023 and January 2024, an international team of astronomers used the JWST's near-infrared spectrograph for the Advanced Deep Extragalactic Survey program. They were surprised by what they discovered. Webb's observations revealed a galaxy with a record-breaking spectrum dating back to just 290 million years after the Big Bang, which equates to a redshift of around 14. Redshift measures a galaxy's distance from us, with higher redshifts indicating greater distances due to the expanding universe. The brightness of this newly discovered galaxy was unexpectedly high for its distance, and its closeness to another galaxy created the illusion that they were a single larger entity. This led the team to obtain new images with Webb's narrower near-infrared camera, which supported the high redshift hypothesis. In January 2024, NIRSpec studied the galaxy, now named JADES GSC14, for nearly 10 hours. Initial analysis confirmed its redshift at 14.32%, along with a fainter companion galaxy, JADES GSC14-1, at a similar distance. This discovery set a new record for the most distant galaxy, surpassing the previous record held by JADES GSC13, which existed when the universe was 13.4 billion years old. The newly discovered galaxies, JADES GSC14 and JADES GSC14-1, are estimated to be 13.5 billion years old. This discovery is unexpected and challenges the very basis of our models, said NASA scientists. Not only is this galaxy the oldest ever observed, but it also shines remarkably bright. The images reveal that it spans over 1,600 light-years, indicating that its light primarily comes from young stars rather than from emissions near a growing supermassive black hole. The immense starlight suggests that the galaxy's mass is hundreds of millions of times that of the Sun. This raises a significant question. How could such a bright, massive, and large galaxy form in less than 300 million years? NASA scientists note that the galaxy's intense ionized gas emissions, visible as bright lines from hydrogen and oxygen, are surprising for such a young galaxy. The presence of oxygen suggests that several generations of extremely massive stars existed before we observed the galaxy. These findings indicate that JADES GSC14 differs greatly from the galaxy types predicted by theoretical models and simulations of the early universe. Among the numerous high redshift galaxies surveyed, no comparable counterparts have yet been found. However, this discovery comes from a relatively small portion of the sky, so there may be even older and more luminous galaxies waiting to be found in the vast universe. Scientists believe that galaxies form in regions where gravity pulls gas and dark matter into dense clusters known as halos. In the early universe, these halos rapidly merge to create larger matter masses. Discovering these early galaxies is crucial for understanding how galaxies like our Milky Way developed over time. JADES GSC14 now serves as a key example of this phenomenon, according to the lead author of the discovery paper. They also highlighted the astonishing fact that such a galaxy could form in just 300 million years. NASA adds that even if this galaxy were 10 times fainter, we might still have detected it, suggesting that even earlier galaxies could exist in the universe's history. And that's it. Thanks for tuning in to Spaceverse. Today, we uncovered the secrets of ancient galaxies with the James Webb Space Telescope and explored the mysteries of the cosmic gems arc. As we push the boundaries of our cosmic knowledge, stay tuned for more discoveries that challenge our understanding of the universe. If you enjoyed the journey, don't forget to like, subscribe, and click the bell icon to stay updated on all things space. Until next time, keep looking up and stay curious.